This is pre-AP Precalculus. This is homework 10.3. For problems 1 to 4, use sum or difference identities to find the exact value of each expression. Something that might be helpful when doing this is just to list a series of multiples of 30. We could go on for a long time here. And multiples of 45. I guess we don't need the 0. And then when we do this, we need to pick two numbers from the list. It could be two numbers from the multiples of 30 or two from the 45 or a combination of either. So I'm looking for two numbers in these lists that when I subtract them, I get negative 15. So this could be the same as sine of 30 degrees minus 45 degrees. According to the difference identity for sine, this is going to be sine of the first angle times cosine of the second angle, subtract sine of the second angle times cosine of the first angle. And the order of these two don't matter. Some people like to put the cosine first and the sine second. Doesn't make a difference. Well, what is sine of 30? Just a quick review. Hopefully you have this memorized, but let's say that you don't. In a 30, 60, 90, opposite 30 is a half. Opposite 60 is square root of 3 over 2. And the hypotenuse is 1. So sine of 30 is a half. Cosine of 30 is square root of 3 over 2. In a 45, 45, 90, both of the legs are the square root of 2 if the hypotenuse is 1. So cosine of 45, square root of 2 over 2. Sine of 45, square root of 2 over 2. Simplify this. This is going to be square root of 2 over 4 minus square root of 6 over 4. Making that one fraction, we get square root of 2 minus square root of 6 divided by 4. Make sure your handwriting is not nearly as terrible as mine. Number 2. Number 2 is in radians. It makes it a little more complicated, but we want to be able to add things together here to add to get 11 pi over 12. So here's what I'm going to do. I'm going to add 9 pi over 12 to 2 pi over 12. Hopefully you agree that 9 plus 2 is 11. Now this reduces to sine of 3 pi over 4, which is a special angle, and pi over 6, which is also a special angle. The sum, I shouldn't have a comma there, I'm sorry, it should be a plus. The sine sum identity says this is going to be equal to sine of the first angle times cosine of the second angle plus sine of the second angle times cosine of the first angle. Hopefully you know your unit circle. Sine of 3 pi over 4 is going to be square root of 2 over 2. Keep in mind this is in quadrant 2. Cosine of 135 or 3 pi over 4 is going to be negative square root of 2 over 2 because we're in quadrant 2 for that. Cosine of pi over 6, that is the same as saying cosine of 30, which is square root of 3 over 2. And sine of pi over 6 is 1/2. Just a quick reminder, I feel like I'm writing way too large for this. That pi over 6 makes this a 30, 60, 90. So this is the short leg, this is the long leg, this is the hypotenuse. And 135, or 3 pi over 4, is going to be here in quadrant 2. This is negative, and the y value is positive. That's why this here, it was a negative square root of 2 over 2. The most common mistake folks make on this is they don't make this negative. I'll make it red for emphasis. Simplifying this, we're going to get square root of 6 over 4 minus square root of 2 over 4. That's going to give us square root of 6 minus square root of 2 divided by 4. Cool. Number 3, cosine of negative 105. I need to add two angles together that are multiples of 30 and or 45 to get 105. And there's multiple correct answers. I'm going to do cosine of negative 45 degrees plus negative 60 degrees. The sum identity for cosine says this is going to be cosine of the first angle times cosine of the second angle minus, it's the opposite sign of this, sine of the first angle times sine of the second angle. Now if you need to draw your special right triangles out to do this, do so. Please keep in mind that cosine of negative 45, that's going to be in quadrant 4. X is positive, y is negative. Cosine of 45 is square root of 2 over 2. In quadrant 4, it's still positive, so it's square root of 2 over 2. Sine of negative 45 is going to be a negative square root of 2 over 2. Because we're in quadrant 2, we went down. And this negative is the part that I'm concerned that you're going to forget. Cosine of negative 60, that's also in quadrant 4. X is positive, y is negative. Cosine of negative 60, that is 1/2 using the unit circle or the special right triangle. And sine of negative 60 is negative square root of 3 over 2. If you need an explanation for that, I'll give it to you. This first picture, if this is 45 degrees, assume the radius is 1, this is square root of 2 over 2. This is negative square root of 2 over 2. Assume it's a unit circle with the radius is 1. And I'm saying this is 60 degrees. Opposite 30 is going to be 1/2. Opposite 60 is going to be negative square root of 3 over 2. This simplifies to square root of 2 over 4. We are subtracting a negative times a negative. So that means we're going to be subtracting a positive. Square root of 6 over 4. This reduces to the square root of 2 minus the square root of 6 over 4. Number 4, we have cosine of 705. I need two numbers that are special angles that add up to be 75. So why not just use 45 degrees and 30 degrees? The sum identity for cosine says this is going to be cosine of 45 degrees times cosine of 30 degrees minus sine of 45 degrees times sine of 30 degrees. Hopefully at this point in your life you know that cosine of 45 is square root of 2 over 2 and that sine is square root of 2 over 2, sine of 45. Cosine of 30 is going to be square root of 3 over 2. Sine of 30 is going to be 1/2. These are all positive because they're in quadrant 1. It's going to give us square root of 6 over 4 minus square root of 2 over 2. This is going to be square root of 6 minus square root of 2. I'm sorry, this right here should be a 4. 2 times 2 is 4. Over 4. Dunsies. 5 through 9. Suppose cosine of alpha is negative 3/5. Interesting. And cosine of beta is negative 15/7. Also interesting. Additionally, alpha is between pi over 2 and pi. Here's what that means. This means this is in quadrant 2. That's what that's saying. Beta is between pi and 3 pi over 2. This means this is in quadrant 3. Question 5, draw and label the reference triangle for alpha. So according to our parameters, we know that alpha is in quadrant 3. Scratch that. Quadrant 2. What else do we know? According to this equation here, x has to be -3 and r has to be 5. This is not a unit circle, but it's still a reference triangle. Well, what is the y value of this going to be? Well, this is a Pythagorean triple. This is a 3, 4, 5. Makes this 4. If you don't recognize that, that's cool. No judgments. Use the Pythagorean theorem, and you'll also find that it's plus or minus 4. We're in quadrant 2, so we have to go up. So that's going to be positive 4. Might be smart at this point to write down that sine of alpha is going to be 4/5. Cosine of alpha is -3/5. And that tangent of alpha is going to be 4/-3. We're going to use those to find some answers to some other questions. Question 6, draw and label the reference triangle for theta. Beta. That beta looks whack. Boy, does that look terrible. Looks terrible. We know that's in quadrant 3 due to our parameters. So this is angle beta. We know that since cosine of beta is -15/7, that x is -15 and that r is 17. If you know your special right triangles, and I'd like to think that you do, scratch that, your Pythagorean triples. This is a Pythagorean triple. It's an 8, 15, 17. If you don't know that, once again, no judgments. I don't hate you for it. Use Pythagorean theorem and you figure out this is plus or minus 8. Since we are going in quadrant 3, it has to be a -8. Thusly, sine of a beta is y/r. Cosine of beta is x/r. And tangent of beta is y/x. They're both negatives, so they reduce to positives. We're going to use that information for later things. Number 7, what is sine of beta minus alpha? Using the difference identity for sine, that's going to be equal to, I'm going to make this a little bit smaller because it's going to get in my way. Sine of the first angle times cosine of the second angle minus sine of the second angle times cosine of the first angle. That is the difference identity for sine. Well, what is sine of b, beta? We figured out that was -8/17. What is cosine of alpha? We figured out up above, it's -3/5. Figured that out right here. And then we're supposed to subtract from that sine of alpha, that's 4/5. And then cosine of beta, that's -15/17. Now it's as simple as simplifying. See what I did there? -8 times -3 is 24. 17 times 5 is 85. We are subtracting a negative, so it's like we're adding. 4 times 15 is 60. 5 times 17 is still 85. Add those little fellows together, we get 84/85. If your fraction reduces, go ahead and reduce it. It does not. Number 8, cosine of alpha minus beta. This is a different identity for cosine, which is cosine of the first angle times cosine of the second angle plus, those signs are different for cosine, sine of the first angle times sine of the second angle. According to information above, cosine of alpha is -3/5. Cosine of beta is -15/17 plus Sine of alpha is 4/5, and sine of beta is -8/17. Just on some quick mental math, because I'm really good at that, we're going to get 45 over 85. Adding a negative is like subtracting a positive. 32 over 85. And that's going to give us 13/85. Dunsies. Number 9, tangent of alpha plus beta. This is the sum identity for tangent, which is tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha times tangent of beta. According to our information above, tangent of alpha is -4/3. Tangent of beta is 8/15. And then we have 1 minus the product of those fractions. Got a little bit of simplifying to do here. I want to get common denominators in my numerator, so I'm going to multiply top and bottom of this by 5, which is the same as multiplying by 1. That's going to give me -20 plus 8 over 15 divided by my denominator. Subtracting a negative is like adding a positive. 8 times 4 is 32, and 3 times 15 is 45. I'm going to change this 1 to be common denominator, 45 over 45. So continuing, I'm going to get -12/15 divided by 77/45. This is a complex fraction, people. One thing I can't stand is a complex fraction. I'm going to multiply this by 1 in the form of 45 over 45. The reason I'm choosing that, these 45s cancel. Awesome. And then these 45s, 45 into 15. 15 goes into itself once, goes into 45 3 times. So we are left with on the top, -36. That's -12 times 3. And on the bottom, 77. That does not reduce. That is what tangent of alpha plus beta is. Cool. Simplify each of the following expressions using a sum or difference identity. Show your work, providing exact values when applicable. This is the sum identity for cosine, or for sine, which is sine of the first angle times cosine of the second angle plus sine of the second angle times cosine of the first angle. Well, sine of x is sine of x. Cosine of pi over 2, that is 0. That's from the unit circle. Sine of pi over 2 is 1, also from the unit circle. 0 times sine is 0. 1 times cosine is cosine, so this is equal to cosine of x. Awesome blossom. Number 11, wow. What, pray tell, is the hotness that is here? Well, it looks like to me the expanded version of the sum identity or difference identity for cosine. Let's see if this works. This is plus, which means it's a minus for cosine. What are the angles we're adding or subtracting? It looks like 11 pi over 9 minus 2 pi over 9. 11 pi over 9 minus 2 pi over 9 would be 9 pi over 9. Well, this is awesome. That reduces to cosine of pi. We know what cosine of pi is. It's -1. Yay! Number 12. This looks very similar. This is the expanded version of the sum identity for cosine. It's a sum because the expanded version has a minus. Our angles are pi over 20 and pi over 5. If we add those together, we're going to need common denominators. It's pi over 20 plus 4 pi over 20. That's going to give us cosine of 5 pi over 20, which is cosine of pi over 4, which is in quadrant 1. Cosine of pi over 4 is positive square root of 2 over 2. More, yay! Number 13. This looks like the expanded version of the difference identity for sine. Sines have the same sign for the expanded and short version. So we're going to have 400 degrees minus 85 degrees. That's going to be sine of 315. That makes a special right triangle in quadrant 4. In quadrant 4, sine's negative. 315 makes it 45, 45, 90. Sine of 45 is square root of 2 over 2. Once again, we're in the fourth quadrant. Sine is negative in the fourth quadrant. Number 14. This looks like the expanded version of the sum identity for tangent, where the angles are 11 pi over 21 and pi over 7. If we get common denominators, we're going to get tangent of 11 pi over 21 plus 3 pi over 21. That's going to give us tangent of 14 pi over 21. That reduces, people. Boy, does that reduce. That reduces to 2/3 of a pi. Nothing better than 2/3 of a pi. Tangent in quadrant 2, which is where this angle is negative. Let's figure out what this is. If it's tangent, I don't like to use a unit circle. Still use a special right triangle. This is 2/3 pi. That means this is pi over 3, which means this angle at the top is pi over 6. If it's tangent and not sine or cosine, I like to call the smallest side 1. It's negative because we're in quadrant 2. Opposite of 90 is twice that, but it's positive. And opposite of the pi over 3, which is opposite 60, which is the long leg, is going to be square root of 3. Tangent is y over x. That's square root of 3 over negative 1, which is negative square root of 3. You can also do this the long way using the unit circle with a radius of 1. You're going to get a complex fraction that reduces down to this. Last one. Look at this little fella. What do you think he's doing? This is the sum identity for sine. This is the difference identity for sine. So the first one's going to be sine of pi times cosine of x plus sine of x times cosine of pi. I'll color code this for your viewing pleasure. The second one is going to be sine of pi times cosine of x minus sine of x times cosine of pi. Well, this looks pretty convenient, doesn't it? This term and this term are like terms. One's positive, one's negative, so they cancel. This term and this term are like terms. I should have an equal sign here. Let me make this a little bit to the right. Since they're both the same, since they're both like terms and have the same sign, now we're going to have two of those. What is sine of pi? Well, I'd like to think that we all know that's 0 from the unit circle. 2 times 0 times cosine is 0. Just a real quick, why is sine of pi 0? This is the location of pi. The y value here is 1. I'm sorry, that's not where pi is. That was embarrassing, am I right? This is pi. The y value here is 0. The r value is 1. And sine is y over r. That's 0 over 1, which is 0. That concludes the homework. Yummy.